Hello everyone. So we have this Leetcode question. It's called toSum. We are given an array of integers. It's called nums and an integer target. We should return the indices of the numbers in num. There are two numbers such that they add up to target. So for example, in this array, we have the target of 9. We see that 2 and 7 add to 9, so we return their indices, which are 0 and 1. In this example, 3, 2, and 4, we have the target, which is 6. We have 2 and 4 add to 6, so we return their indices, which are 1 and 2. The question says that it's guaranteed there is exactly one solution. So how do we think about it? Let's go to the canvas and take the example with us. So we have 2, 7, 11, and 15, and the target is equal to 9. So first solution that comes to our mind is usually the brute force approach. So the brute force approach in this problem would be that we search for all the combinations of two numbers and x and y such that x plus y is equal to the target t. So in this case we should make two nested loops. So for example, we take first the number 2 and try with it the number 7, 11, and 15, and then we take the number 7 and try with it 2, 11, and 15. Then we take the number 11 and try with it 2, 7, and 15, and the same for 15. We try 2, 7, and 11. If you notice, for example, we tried 2 and 7, the combination of 2 and 7, we tried it here, and we also tried 7 with 2 right here. So we can notice that. Let's put the input array again. So let me clean this up a little bit. Okay, so we can see that if we tried all the combinations with number 2, 7, 7, 11, and 15, when we go to the number 7, we don't need to try 2 again because we already tried 2 and 7. So we only try the numbers that are after it. And also for 11, we try it only with 15. With 15, we don't try it with anything. So this would be a solution. And actually, it will be an O of n square solution, because we will be making two nested loops inside each other in terms of time complexity, and O of 1 space complexity, because we will not be using any additional memory to store the things that we need. So let's go and see its implementation, and then we will come to the optimal solution. So we will make two loops inside each other. So for I in 0 until nums.size, and for each index I, we will go for j in I plus 1 until the size. For each I and j, so for each combination of I and j, we will check if nums of I plus nums of j, if they add up to target. So we will return an integer array of I and j. So these are the indices, and it's does not matter in which order we return them. And to make the Kotlin compiler happy, we should return at the end of the method, because the Kotlin compiler does not know if we will reach a solution or not. So let's try to submit our solution. And it only beats 28% because it's not the optimal answer. So let's go back to our canvas and try to find the optimal answer in this case. If we look closely at the problem, so we have this input array, and as we said, the target is equal to 9. What we are searching for, let's say that we are iterating over the array, and we are here at the index I equal to 0. So we are carrying or we are looking at the number 2. So the current number x is equal to 2 and the target is equal to 9. What are we searching for? We are searching for number y such that x plus y it's equal to target t. So the number y we are searching for, it's equal to t minus x. In this case, it's equal to 7. So when we are standing at this position, we are searching for the number y is equal to 7. Okay, do we have number y equal to 7 that we have seen in the array until now? No, we do not have. Okay, so let's go to the next number. So we are standing now at the second number, x equal to 7, and the target is still equal to 9. So now we are searching for number y, which is equal to t minus x, so it's equal to 2. So we ask ourselves, have we seen 2 in this array before? Yes, we have seen 2, and its index is 0. It's right here. So we have reached an answer. So we just return the current index, which is I, and the j, which is the index of the number y. So now our question is, what data structure, or what is the way that we should use to answer the question, such that if we are standing at any of the indices, we want, when we ask a question, have we seen the complement before? The complement is this number y. We want to answer it immediately in O of 1 time complexity. We don't want to search the whole array. So what kind of data structure gives us lookups of time complexity O of 1? And also this data structure should not only contain the number that we have seen before, it should also contain at what index we have seen this number. So this data structure should contain pairs, or two pieces of data, the number and the index. So combining these two requirements, we can see that we need a hash map. So for each number, we will have a hash map. It will be comprised of key and value pairs. Let me clean this up and trace the solution that is now sort of obvious. So at the first iteration, we will have I at the index 0. We will ask ourselves, now x is equal to 2. The complement, let's call it y, it's equal, and the target is equal to 9. So y is equal to t minus x, which is equal to 7. So we will look at the map right here. And we will ask ourselves, have we seen the number 7 before in the map? No, it's still empty. So we will only register the number 2 as one of the numbers that we have seen. And we say that number 2 have been seen at the index 0. And we will go to the next number. So now we are at number 7. So x is equal to 7 and y is equal to t minus x, which is 9 minus 7, which is 2. Now we will ask ourselves, have we seen this complement before in the map? If we look at the map, yes, we have seen it right here. And this question that we asked ourselves, it takes O of 1 time complexity, because lookups in the hash map take O of 1. And this is why we are storing the number right here and not right here, because when we want to look up, we want to look up the number. So we can only look up by the key in the hash map. So that's why we store the number under the key and not under the value. And instead we store the index under the value. So now when I is here at 7, we ask ourselves, have we seen the complement, which is 2? And the answer is yes, we have seen 2. At which index we saw 2? We saw it at this index right here, which is the value of the key, which is 2. So now we have our answer. Our answer is the index of 2, which is 0, and the index of 7, which is the current I that we are standing at. So now the solution is obvious to us. Let's go and code it down. Let me erase this old solution. So we will need the map that we talked about. So it will be a hash map of integers as a key and integers as a value, and it will be empty initially. We will have only one loop, so this time the time complexity will be O of n and not O of n square, but the space complexity have now increased. It was previously O of 1 and now it will be O of n, because we are using extra space that is proportional. In the worst case, it's proportional to the size of the array. So for I in 0 until the last index of the array, what we are going to do each time, we are going to calculate the complement. So the complement will be equal to the target minus the current number that we are looking at. And now we will check if the map contains the complement, we are going to return the answer that we have found, which is an integer array that contains the indices of the numbers that add up to the target. In this case, the indices will be the index of the current number that we are looking at, which is I, and the index of the complement that will be map of complement. And we should put these exclamation marks because this is nullable. And at the end of the array, before reaching the end of the array, after this if this if is not going to execute, so this means that the map does not contain the complement, so we just want to register the current number in the map so that if we ask about it in a next iteration, we can find it. So we should say map of the current number, so this will be the key, it will be equal to I, this will be the value. So we are sure because the problem says that there is exactly one solution, we are sure that we will never get out of this loop without returning at some point the answer. But because the function returns an integer array, we just need to return something here after the loop. So we will return an empty array, and let's try to submit our solution. And it passes, and it beats most of the answers, probably due to some JVM slowness. So that's it for today's video. Thank you very much for watching. Please like, share and subscribe to the channel to see more of these videos and to support me. Thank you very much, and see you in the next video. Bye bye.